Hello everyone, good morning. Welcome to the workshop, Airflow workshop. Like today we are going to discuss about the workshop things for the Airflow. So the main agenda of this workshop is to discuss the real-time end-to-end live ETL pipelines. For this process, we're going to see the integration between the multiple services for different ecosystems. So first, let's start about the introduction part. On the introduction one, so first we'll see about like what is our agenda. So in the agenda, if you see the process, first we'll discuss about the introduction to the pipelines, how the pipelines will configure. First of all, we'll see what is a pipeline and how we can integrate and how the use airflow will be useful and what are the different key technologies internally. And next, we'll see the pipeline architecture, like starting from the source to target, how pipeline is designed, the process, and what are the key concepts of Airflow, Apache Airflow key concepts. And we'll see the hands-on. Today, we are going to see the real-time pipeline deployment by doing hands-on so that you can practice the same on your side, on your mission as well. And we'll see how this can useful for the real world use cases, where exactly we can fit this type of solution into the requirement level. And best practice and tips like how we can monitor and uh, how we can monitor the logs and how we can troubleshoot if they have any issues on the real time deployments. So Airflow is a very friendly way of connecting the log integration, and it's a best UI. So I'm going to show you that how we can use it, how we can troubleshoot, and at the end, if you have any Q&A, yeah, I'm happy to answer your other questions. Yeah. Okay. Now let's start. Let's go with our next action. Is first we'll see about introduction to data pipeline. So first of all, let's see, guys. What is data pipeline? So everybody call as a data pipeline. There are multiple tools are available in the market, but what exactly the pipeline is going to work? So we'll see very simply where pipeline is nothing but is moving data from one source to other source. For example, let's take if you take a river full of water, right? And the water is coming through the pipeline to our home, right? How is it a one time? No, it's a continuous, right? The water is coming continuously. The same way, just imagine on your data flow between source to target is actually nothing but the moving a data. So while moving a data, what actions we can do? We can extract from the source, like nothing but get the data from the source. And we can add your transformations and you can load. Like the same way as I said, the layman example, like from river to our home, is the water is coming directly from river to home? No. So in between, there is some filtering is going on, right? We're adding some minerals, right? So they're doing some cleaning, right? Like the same way, even for data flow from source to target, we are using the ETL process like extracting, transforming, and loading. So this is the common process. It doesn't matter you using Airflow or Kafka or any other systems. We followed the same process of ETL. So today we are going to see how Airflow is going to fit in this pipeline process, how effective it is. That's very interesting because now we have so many tools in the market. Why Airflow? What exactly is going to do? So we will see that in the next slides. And basically, when you say the real-time data pipeline, yes, it is data pipeline. Yes, the ETL will follow, but it's a continuous pipeline. That's called the real time. So whenever the source is ready, immediately it will generate the data and it process. Like if you take IoT devices, real time, weather, tradings, the stock markets, right? So everything. So nowadays, AI is going to capture everything, right? All the sensor activities is going to perform this type of the pipeline ingestion. Today, we are going to use one of the real-time sensor to read this real-time data and to ingest that. So I will definitely call this as a real-time pipeline because we are using here sensors to use the process, and we are going to integrate the hooks and operators to support the whole pipeline process. Okay, let's jump into the key technologies of this workshop, what we are going to integrate. So here, first we are going to use the API. Like in the source, there is a application. We are using API process to integrate that real-time application, and then we can connect to the Airflow. What do you mean application? In the source, it depends upon your data, depends upon your company applications, the source applications. They'll give you access to the API integration. So you take that access and you can integrate. For example, like weather services, financial markets, social media platform, everywhere you see the API connectivity, right? Now we are going to take one example for open source API for this workshop. So you can use the same process in your real-time API connectivity. And once your API is ready, the next step is we are going to use Airflow. So what is this Airflow and how we are using this connectivity? Airflow is a powerful orchestration tool. It is going to organize, it is going to manage, it is going to control your end-to-end data flow. So it's going to manage your old workflows so that we can design that ETL pipeline, and you can schedule that ETL pipeline, and you can monitor the internal tasks of the ETL pipeline. And if you have dependency, yes, in the ETL, T to L process, right? So it means T depends upon E, L depends upon T. So how the dependencies can capture. So we're going to see it's a single centralized platform where you can take care of all these scheduling things. Like we have, in the market, we have so many tools. Why Airflow? Airflow is a one, I'll call SSOT, single source of truth layer, which contains everything. It's like a master layer. So that's why we recommend to the clients use Airflow to orchestrate your jobs. And I'm taking one database. You can take any database at the destination. So I'm just taking a Postgres. So we can take the data from API to Airflow, and we'll ask Airflow to load the data into Postgres. So, Postgres is one of the RDBMS. We can maintain and we can store, manage our data from the APIs easily when you're connecting through this way of scheduling. So what are the key concepts we have? So if you see this diagram, you can easily understand the data flow is actually a one way. It is not a cyclic, right? It is not coming as a loop. It is going to the one way. That's why we call DAG, direct acyclic graph. So in this direct acyclic graph, we have a dependencies. For example, this task is depending on this task is depending on this task, and this task is depending on this task. So we have dependency and everything is going through the pipeline. It is not a circle. It is a cyclic graph. So it's going on one way of direction. In between, we are using operators we'll taking care of operators support to use this pipeline. Suppose I want to apply some Python functionality. Yes, you can use a Python operator, or we have a scheduling operators to schedule the jobs. For example, I'm integrating the Postgres database here, right? You see this Postgres database here, I'm integrating, right? So for this way of connectivity of this pipeline, we require the operator. We're going to use the Postgres operator. The same way, if you're using suppose SQL Server, Oracle, or anything, we can use depends upon your destination, you can use that operator in the process. So this is the key concepts. Now let's see what is our architecture. So this is our workshop target. This is our agenda today. We are going to see this end-to-end pipeline by hands-on, practically. We can do the step by step. And at the end of the session, we are going to save you the resources and you can practice on your end. So this real-time data pipeline is nothing but I'm taking one open source API, real-time API, and that API I'm connecting to the Airflow, and I'm asking the Airflow, okay, you take data from the API and you load into Postgres. And I'm asking to orchestrate this daily job. So this is the daily job, one of my client's requirement. So I want to schedule this daily basis. So this is a real-time ingestion, right? But why I call pipeline? So pipeline is a process where we are going to ingest the data on a regular basis, right? We are ingesting data on continuously interval of time, like daily or weekly or hourly or monthly or yearly. Based on your requirement, we can schedule this. And if you see something new here is called DB Viewer. I like to play with the DB Viewers because using a DB Viewer, we can connect to any databases easily, right? Now we are going to see practically how we can interact. For example, every database, they have their own UI tools, like Postgres is a PG admin, SQL Server is SSMS, and for Oracle Toad, like that, we have UIs, right? Instead of going with the multiple UI for multiple databases, we can use one UI which can support every database. That's we call DB Viewer. So we're going to see how this integration will happen. Yeah, now let's see the steps. What are the steps in our demo? We're going to see the step one. We're going to fetch data from the API, okay? And we're going to fetch this connectivity, and we are going to transform the data on the step two by using the Python operator. And step three, we're going to load our data into the Postgres. So this is the agenda today, the flow of our workshop, the hands-on. Okay, now let's see. Now let's see how we can do this pipeline by hands-on. And after that, if you have any queries, we can see, we can discuss on that. Okay, how Airflow is going to work. So for the installation Docker steps, I will share you the documentation of how to install the Airflow Docker. I request you please go through that installation process. Now we are going to see directly the Docker steps. So this is the Docker Composer file. I'll share you this file after the class with the resources. You can see here, this Docker Composer file is as everything. So if we're going to install this Docker directly, the required services in your local machine, we can just do the Docker uh, Composer -f. You can just Docker Composer up -d. So it means it is going to install now all the Docker services. So if you go and check in the Docker, you can see here this Docker. See, it's all running. When you see green, means it's all running. Just you can just run again. If there is anything missing, it is going to up the services. Just to to verify is Docker is installed properly or not, I'm just going to take one of the service. Yes, this is the portal. You can just use localhost 8080 and you will get the Docker like this. So if you got this UI, it means Docker is working perfectly. Okay, now we are going to see one DAG. I'm going to create a new DAG, nothing but new job. So what is this here? As I said, DAG is direct acyclic graph. We're going to define multiple tasks in this. So I'll just call real-time real-time ingestion pipeline .python file. Okay, we just started the Python file here. So now what I'm going to do is I'm going to start the coding part. So in this process, we're going to work with the multiple steps. First, we'll import the DAG from Airflow. And I'm going to use the date time. I'm going to call date time. I'm going to use the Postgres import. I'm using the Postgres operator. So we are using this operator for what? For at the end, we are going to sync data into Postgres, right? For that. And as I said, we are going to use sensor data from the API sensors by using the HTTP sensor. So you just can import HTTP sensor. Okay, and we need to use the Airflow from Airflow dot providers. I'm going to use the HTTP operator. We're going to use this operator to download the data. And then finally, I said I'm processing data, right? I'm doing transformation, right? For the transformations, we are going to use the Python operator. So everything is available in the Airflow package. Now I'm just going to import the required operators. That's it. And finally, I need the hook containing the database. We use the hook. So for the hooks, I'm going to use the Postgres hook. So use the Postgres hook. Right. So we are ready. And I'm just going to use the JSON because when you download from the API, you'll get JSON format. And I will use pandas. If anything, I want to normalize the JSON data. It's a very good way of normalizing using pandas. So these are all the required packages we have. So yes, we imported the libraries, and now we are going to start the connectivity of the DAG. So always start with the DAG. As I said, DAG is a direct acyclic graph. Yes, I'm going to use the DAG ID. In the DAG ID, you can use your name of the DAG. So you can just use the name of the DAG. Suppose I'm using my DAG name as my Python file name. You can just use, I'm using this DAG. And now, how this DAG you want to start? Again, can you just use some start date of the DAG? Suppose I'm just calling the start date. I want to start already the old dates. For example, let's say I'm just doing some random date. At the end, I'm scheduling this daily so that it can start from today itself. So schedule interval time. When you want to schedule this DAG, so I want to schedule this DAG by daily. Okay, that's good. And catch up is equal to false, which is nothing but is going to catch up the false things, right? And now this is a basic DAG parameters. Now I'm going to start the actual DAG. Okay, first of all, what is our step? As we discussed in this process, first we are going to set the Postgres table creation because when data comes, first we have to make a table structure, right? So, and the Postgres side, I need to create a table first, the empty table, so that when the Airflow lands the data, When the Airflow lands the data from the Airflow to Post, will go to the table, right? Like this, you can load it. First, let's make a table first. Okay, right. Now I'm going to create a table directly from the Airflow pipeline. Actually, you can create a table separately in the Postgres and you can use it here. But instead of that, now today in the workshop, I'm going to show everything from Airflow, even the creation, loading, everything. So let's see now. I'm going to call task called create table. As I said, guys, we have to use the Postgres operator, right? For because I'm counting the Postgres database, Postgres operator. So task ID, just give some task. Suppose I'm just giving the same name of my task ID. What will happen when you start this job? The tag ID is this one. Within the tag ID, the internal task is this task ID. That's it. And what next? I want to use the Postgres connection, right? So Postgres connection ID, but we have not defined, we have not created this Postgres connection. Now we are going to create a connection. So if I go and this run, so I'm just going to create a table, not exist users. Okay, I know there are some fields I have already from the API. So I'm just making a format of what I'll get the source. So in real time, when you're working on your use cases, you know how the API is giving the attributes as you create a data modeling. You'll get to know what is your attributes and everything from the source, right? Based on that, you can create. But right now in this workshop, as I know the some field names, because it's an open source API, anyone can see um, the attributes. Now I'm going to take country. So why can't I use just same formats as it just a workshop? Username. Okay, and I have a password. Password, login, sorry, email. Okay, yeah, okay. I'm going to close this. Right, perfect. Okay, right. So we created a table, but do we have this Postgres connection created yet? No. I just defined some name. Now we need to create Postgres connection. Okay, how we can do? So in the Airflow, when you go to the admin, you see the connections. I'm going to add the connection. What is the name here I've given? Postgres connection is Postgres. Okay, I'll store this. Connection type. So here you can see every source connectivity. You'll find everything. If there is not finding anything, you can go to the ODBC or via JDBC connectivity also. Okay, now I have already Postgres connectivity. By default, the plugin is available, but you need to give all these details, the required details. You can use some description. Host name is mandatory. So what is the host name here? So I think the host name is the local host because you can find everything in this Docker Composer. So yeah, Postgres, see, username Airflow, password Airflow, database is Airflow. But what is the host name? I don't have any host name here. I think let me give a try for the Airflow. I think here I can see the Airflow. Let me give a try. And what else? Yeah, login name. What is login name? Airflow. What is the password of Postgres? Airflow. Right? Let's give a test. I'm not sure it's working or not. Could not true. Yes, it's not the host name. Okay, then what is the host name? As it's my local machine, I'll just try local host. Test. Even it's not the local host. Let me use Postgres. I think this is our host name. Postgres. Yes. Let's give it a try. Yes, successfully connected a connection. Okay. So by this way, so I know the host name is already Postgres, but why I'm showing you this, you need to be clearly understand what exactly when you're playing with this host name. So in real time, your database team, they'll give you these details. It is not our job to create. It is the job from database time team. They're going to give all these details. Okay. So but you need to try these ways how the connection is working. Okay, fine. The connection is ready. I'm going to save the connection. Okay, Postgres connection is ready. So which means that in our project, you see the Postgres connection is ready. Okay, next. Okay, once the table is created, what is my job? Next, my job is, so this is ready, right? As I said, this is ready. Now the next step is I'm going to create a API. So as this is ready, once the API is ready, and then I'm going to use the Airflow to integrate the next process. Okay, so this is the task one. So just remember, this is the task one. What is the task two? This is task two. This is task two. Okay, now we're going to task two. The task one is done. Next, what is the task two? Let's check is the API is available or not. So I said is API, but do we have a connection created? No, I just created only Postgres connection. So now I'm going to check API available. API available. So I'm going to use the HTTP sensor. So I'm just taking task ID. So I'm just checking. Just always use a lowercase better. Yeah. Use the same task ID here. I'm going to use that connection ID. And the endpoint. What is this actually? API, right? So I'll give the endpoint. It's a API. Connection ID. Yes. I'm going to call API connect like this something. So I'm using this connection. I'm going to add a new connection. And what is this connection? HTTP connection. And then, so what is the host name here? So basically on this one, we are going to connect the host name details as there is a open source API available. I'm going to use that API, random user dot me. This one. And then I'm going to use this connection. Okay, let's save. So I just saved this connection. Yeah. So once the Postgres connection are ready and API connection is ready, so the next step is now I'm going to check the API. So we define API connect. Yes, API connection is ready, and the endpoint is also ready. So I'm using this endpoint connectivity. Let's put in a single quote. Okay, that's the endpoint API. Okay, now the next step is I'm going to extract the user. So now let's see, we're going to connect the HTTP sensor with the API. And the next step is once the API connection is ready, let's start extracting data. So T1 is ready, T2 is ready. Now I'm going to create T3 for extracting data. So on the extraction user, let's see, extract user. I'm using simple HTTP operator. extract user. HTTP connection ID, user API. And now I'm going to give our endpoint is equal to API endpoint, right? Right. And what is the method you're using for the HTTP? I'm going to use the get method because I'm getting data from the API. Do you know what is the response we'll get? JSON response. So now I'm going to use the lambda response JSON dot loads response dot text. Okay, you just log your response. Yes, I want to log response. Make it true. And that's it. I'm extracting user. And once user extracted, you have this JSON format, right? But here I have table, right? So now what I'm going to do, I'm going to process. I'm going to process. And then I'm going to store. So we have two more steps is store. So first one is, what is a T1? T1 is for create table. Okay. And what is T2? T2 is for API check. What is T3? Extracting user data. What is T4? Process user. What is T5? Store user. That's it. So creating a table completed. Yes, API check completed. Extract user is completed. Next, I'm going to write the process user. For the process user, this is the way we call transformation, right? This is all extractions. And now this is transformations. So if we define our pipeline as E and um, the T for transformations. So if you call this as pipeline ET and the loading, we have L, right? So L. So in this process, so we have finished now E, and now we are going to T, and now we are going to L. What is this meaning? Extracting, transforming, loading. Now we are doing a transforming part. This is nothing but T4, called process, nothing but transformation. On the T4, I'm going to call the process user. And remember, every time I'm using some operator, right? So here I'm going to use a Python operator. In the Python operator, I'm going to define the task ID, process user. So taking the task ID, process user, and Python. As I said, a Python operator, I'm using the Python callable function. So I'm going to use a function. I'm just defining that the function. I can call like this define function, something like this. I can use it. So now I can use the function. What is the function will do? I can just put here the function, and then I can write the logic. What we received here, the received is the JSON format data. I'm going to define the function I'm going to use the user. I'm pulling the data for external system, calling the task ID. Whenever the task IDs are requested, I'm calling this called extract user, and I'm taking the JSON format. The results of the payload you will get as a results. Processed user is, I'm going to normalize my JSON data. The format of the normalization, as you know here, our fields, first name, last name, email. So I can use this. First name, last name, country. I can normalize by JSON format so that I can store these results into CSV. If you see that JSON normalization I'm using for pandas because I want to make a table, I want to load it as CSV, and then I can store the results into actual table. Okay, first name. User of name. Because here, as I said, I'm storing everything in a user, so I can just use user. And in the name, the first is actually the format. So in the when you see the API, you will know all these. What is the format? Where our data stored? Can I get the requested format? Do you have to transform the requested format? Currently, what I'm doing is I know this format as JSON. By default, it's JSON when you do API anyway, but you can transform what are the format you want. Okay, so now, okay, now I'm going to go to the password. I'm just defining here like this. Okay, now all these available. So I'm taking that last name, first name, last name, country, username as username, password is a password. For email is actually in the email format. We can use it. But for country is actually comes under the location because in the JSON format, we have internally, there are internal attributes. That's why we can use this format. Yeah. So like this is the format we have. So we are what we are doing is we're taking a JSON data and we are organizing the required format. And all this data now stored into the user, which these are all the fields that we have defined. And now I can download this data to a CSV format. You can check. Okay, for example, now where is the results? This is the result. What I'm doing. So I'm taking this process user to CSV file. If you observe here, from the API, I got JSON format. Within Airflow, I'm taking that JSON using a Python internally, and then I convert it into a CSV. Okay, so here internally on the task 4, I'm converting a CSV. Why? Because CSV loading is very easy into databases, right? What is CSV, comma, separate to value. It's all a structured format. So where do you want to store? Okay, I want to store it to my temp location. User processed user dot CSV. Okay. And do you want index? I don't want index because I want loading into a table. Index, just give, sorry, not true, none. You want header? I don't want header because I'm not defined schema. So if you're downloading for your actual CSV purpose, you can put the header true. I'm not downloading for, basically why I'm downloading for to load the data into Postgres. For that, I don't require any header. So this is why I put the temp, because it is stored temporarily into the Airflow, and then it will go to Postgres. Okay, we are good. So we completed process user. So T3 is done. Okay, so we completed T1 table creation. We completed T2 for API connectivity. We completed T3 from API to the file conversion. In the T4, we are normalizing the JSON data from the response. And now the final step is T5. So T5 is the final one where it's going to store into Postgres. So I'll go quickly. So on the T5 step, which is target store target store user. Let's say, for example, I'm using same I'm using same Python operator. Why? Because we're using Python, we are going to call the function. So now, while storing the results, so I'm just called task ID first. I'm using the same task ID. Remember, always I am always using my functionality task ID same. Even for the DAG, if you observe, the DAG ID is the same name of my Python file. It's not mandatory, to be honest, but it's always better to use the same so that we know what we have used. Um, so let me call Python callable to user, suppose. Now, this is a function, right? I will call def so that we can understand the definition. It's a function. Okay, now let's create def function because I'm calling a function called def underscore store underscore user, and I'm going to create a store user. So this is nothing but what is our job? My job is to take the CSV file, right? Load into the Postgres. So where is the CSV file? Temporarily loaded into TMP, right? Temporary location, right? Okay. Now I'm going to hook. I'm going to use a hook. So as you know, we have defined Postgres hook and define the Postgres connection. I can use it as we have already Postgres connection ID, this one. What is the connection ID? Postgres, yeah, same name, Postgres. Okay. I'm using same connection. We have already used the connection for what? To create your table. Now we are going to use the connection to load your data. That's it. Connection is same, but doing different job now. I'm going to load SQL command, copy data from my input. What is the delimiter? I said CSV, right? What is delimiter with CSV? Comma, right? Comma separate to value. Okay. So we can use delimiter alias. So here, comma, right? My delimiter is actually comma. Put the comma and close this. That's it. We have completed. Now, but give the source also. What is my file name? Where we stored the file name? Into temporary location, right? Yeah, this one. Same path I'm giving to store the file name. That's it. So here we stored as a one file name. So the file name we are loading into the taskbar. Yeah, I think that's it. We have completed. But if you observe, I'll show you. Let's see. Now, let me run. So on the process user, you see here, I'm going to use Python operators. Yeah, I think that's it. If you observe here, we have different jobs. Okay, so now we're going to trigger the DAG. Now you see the execution step. Before that, first let's see this connection, Postgres to my DB viewer connection. Okay, because at the end you see the results in the Postgres that we are going to see in DB viewer, right? Before executing a DAG, now let's see how DB viewer is going to show you the connections. So let's establish a connection from Postgres to DB viewer. Um, Let me close the connectivity. I'm going to call, you can see here, this is what I like in this tool. You have a single tool where you have multiple databases connectivities. You can connect Hive, Athena, like it doesn't matter is a cloud or on-prem, you can connect it. Okay, now we're going with the Postgres. Click next. Host name. Uh, this is also we have to check. What is the host name we have given here? Postgres. I think this is localhost. Okay, and what is the details we have given? Host name, just give it a try because it's internal database. And this is actually Airflow, right? Database is Airflow and username is Airflow. Password is also Airflow, I think. Let's give a test connection. No, connection failed. And there's a local host. You can try local host also. In real time, you'll see the IP addresses, everything your DB will provide. But now see, yes, it's connected. Okay, click OK, click finish. Now on the Airflow connection, do you see here tables list? So suppose I'm going to call instead of users, let me call users final just to make sure that the table is not exist. I would like to show you that users final. Do you have table? Yeah, users final. Oh, sorry. Just use users final. Okay, that's good. So now what is our table? Users final. Do you see the table name here? Airflow, public, Airflow, users final? No, right? I don't have any data. Do you see any users final table? I see we have only users. I don't have any users final, right? Okay, now it will come after we trigger the tag. Okay, now my DAG is ready, and let's go to the DAG, and you can check, do we have any errors in this? Yeah, this is our actual pipeline. Ignore the other pipelines, this is my other jobs. What is showing? Cannot import HTTP sensor. Spell mistake, I think. Import HTTP sensor. Okay. Okay, just refresh. We have still 3 more. Okay. Any errors? No module named. It's actually HTTP, right? HTTP operator. Okay. Any more errors? I see 3 more. Airflow providers, HTTP operators. Just check from Airflow providers, HTTP. Okay, this one is just simple HTTP operator. Okay, right, perfect. Let's refresh. Now you can check. I think there is a small one, which is actually hooks. There is a hook, yeah. For the hooks, it will come from the Airflow providers. It comes from the hooks actually. Okay, let's refresh. It's good to know all these errors before we triggered. Anything else? What is the issue with the catch up? So on the catch up one, it's actually lower cases. That's good. Line 56. So always you have to troubleshoot this way. So I'll always make some mistakes while giving the workshops or sessions because we know where exactly we are making a mistake. So or else I can simply copy paste the code and I can show you directly. So endpoint is always a single property attribute. What next? Yeah, user API. Actually, it's not user API. Where is the line number? Extract user. Okay. You say user API. Actually, for what is the connection names? API connect. Okay. Use the API connect. Yeah. Okay. And we have API connect. API connect. This is actually CONNN, right? So we used above CONNN, right? The same way. Okay. Anything else? Task I extract users. Okay. So what is the issue here? So on deploy 0.7 function, invalid argument, users. Does the task IDs? Perfect. Okay, let me refresh and here refresh. I think there is issue with task ID. Let me check where I have used task IDs. Task ID. Okay, task ID for HTTP sensor API available. Just use always the lower cases better. And API connect, yes, API connect, HTTP sensor, and simple HTTP operator. Yeah, a simple HTTP operator. API connect, okay. Endpoint, we used API. Method is we used get and response. This is showing some syntax errors. Okay, now we don't have any else. These two are different jobs anyway. Yeah, what is our DAG name? Yeah, real-time ingestion pipeline, right? Our DAG name, your project name and DAG name. So if you see here, you will see that name, real-time ingestion pipeline. See? And if you see the graph, do you see the dependency between tasks here? No, because it's taking all tasks, but it's not showing independency. Then what will happen? When you click the button triggering the DAG, all will fail. You know, see, it's all failing. Why? Because these have a dependency. So the process user has a dependency for the table creation. Target store is depending upon process user. If you didn't put the dependency, jobs will fail. The whole DAG will fail. So you can see the grid, the DAG is failed. So one automatically distribute trigger now. One I just press the trigger button, right? When you start first time, it will take automatically. Okay, now let's see. What is dependency? Dependency means what is the first task you want? So here we discussed what is the first task? Create table, right? Create table. What next? API test. Is API available? Checking. Next, what next? Extract user, right? Extract user. Next, what next? Process user. So you need to see, that's why I said DAG, direct acyclic graph. It's not a cycle. Say pipeline. So this is target store, right? So now if you refresh this one, you will get a dependency. See, you got dependency, right? You got all the arrows, right? Task 1, task 2, task 3, task 4, task 5. Now, if you run, you will see the execution steps one by one. So create table ready, API available ready, done. You see all the greens and you can see all the status. So I have shared one more article last week, I think, regarding the life cycle of DAG for all the states. So we will share you that in the part of the resources. Please go through it. You'll get to know what is the status and everything. So now I'll just discuss you high level. Like you see the different statuses here. Now the thick green means success and light green means running. So what we are doing here is first table creation is completed, API available is completed, user extraction is completed, process user completed, targeting also completed. Now let's check. As we discussed in our slide, in the previous slide about like how we can monitor, how we can handle the logs and everything, so you can check. If you go to the job, see what is the first step? Create table. So the log is showing, okay, the table is created, is making as a success. That's the first task. And if you go to the API available, then it is going to check the API connectivity and success criteria met. If it is a met, then it will trigger the other tasks. Remember, this is sensor which is running continuously. If there is no connection is not ready or connection data is not ready, it is going to keep on run on the back end. So now I got the connection is ready and I got it as pulled. That's why it's triggered the other task called extract user. So here we're extracting. See, this is the what? See, do you guys can you see the data here? You can see data here, right? As a JSON format. As a JSON format, you can see. And that's why we use the process user to take care of the JSON and converting into a proper CSV format. So, and once that is done as a Python job, and it's going to download the data into CSV to copying a data from CSV to table. Okay. Now this is the time to check our output. What is our input? Our input is already showing here in the real-time job. What is our input on extracting user? This is our input. This is our input. As it's the API, it will come one by one record based on the availability of the source. Now this data will go to Postgres, right? Let's check. Where is the Postgres? We just use the DB viewer to use the Postgres. Do you think is this table is ready? No. Let's refresh. So if you click the refresh, then you're going to synchronize all your things. So now I'm just going to just define the connection. The database name is Airflow, right? Because if you check in our Docker Composer, it's already clearly mentioned our Postgres connections. Because while this, yeah, Airflow. Airflow is username, Airflow, password, Airflow. Test connection. Yes, it is success. Click OK, click finish. Now this is Airflow 6. So if you go to this one, databases, Airflow, schemas, public, tables. Did you receive our table name? Yes. You see here, users final. We got it right. And if you select your data, so I'm going to execute. We can just do we can generate a query here automatically. You don't need to do manually. I'm just copying here. And I'm going to this database. I'll write a query editor separately and paste here and run. Here we got the data. Okay. So whatever the data you see in our here, see Shabari, right? Shabari, first name. So like this, all this data, right? You can see. You got it? This is the open source API. So you see some random data and data will come some interval of time based on you pull. Right? If you pull number of times, you get number of records. It's open source. In real time, what will happen? The same process. In real time, what will happen? The same process. Your client will give you some API details, including that shell scripts, activities, and everything. And then the process is same, everything same. Only change is the connection details. So right now we are playing with our local connections. In real time, you're going to use your client connections. So that is what we have this workshop. So as part of the workshop, so we have covered very well. We covered the step one, fetching from the API, using a sensor, we retrieve the data, and using operator, we pull the data. Step two, we transform, and step three, we load it into Postgres. So by we define this workshop architecture, so every step we have completed. So what are the advantages here is it's a real-time pipeline, everything in a one UI. As I said, guys, you can access everything in a decentralized UI. Okay, and you can access all your DAGs and you can check your connections. Okay, and then you can monitor all your the logs and everything also. Okay, and you can see here how the jobs is running, the logs details and everything. So and whatever the code you defined in our local pipeline, now it is mounted into this UI, and you can see also. So we just started this. And remember, airflow time is always 1 hour back to your regular zone. Always it will show 1 hour back. Right now in my UK time, this is, but yeah, that's the one is there. Okay, I think we are good. We've completed the job, and I'll share you these resources and everything.